viewers, welcome to today's lecture on the course CEC 309 Construction Technology. So today we're going to look at typical costing methods for construction plants, and we will look at the first one is to be able to know how to calculate hourly rates. And to calculate hourly rates, we will use two methods. The first one is the straight line or simple method, and the second one is interest on capital outlay, which is the commonly used or more accurate method. Then the next thing we'll also want to calculate in this lecture is output and cycle times. So these costing methods are useful for us to know, or to be able to know the cost of the cost we incur while trying to hire or purchase construction plants, to be able to know how to the costing method to use when leasing out or when using construction plants on site. So let us start properly. Before we start, please viewers, like our video. If you like this video, please also subscribe to our channel by clicking the subscribe button. And if you want more videos, or you want to stay up to date with our new videos, you can hit the bell icon or the notification button. So let us start properly. The first one we'll look at is hourly rate. So we want to see how to calculate hourly rate for construction equipment. So hourly rate for a construction equipment, we said a construction plant with a capital cost of ₦1 million and anticipated life of 5 years, and total years working of, or total working years of 1,350 hours. Its resale or scrap value is 90,000. Beg your pardon, let me start again. Hourly rate. A construction plant with a capital cost of ₦1 million and anticipated life of 5 years, and total years working of 1,300 hours. Its resale or scrap value is 90,000. Calculate its annual and hourly depreciation respectively if 2% is for insurance and 10% is allocated to maintenance. So looking at the question, the cost of the construction plant is ₦1 million. That's buying it. Then it is expected to work for 5 years under a total hours of 1,350. Then its resale or scrap value, that is having served its or serve us for 5 years under 1,350 hours, we're expected to resell it. So the resale value or the scrap value is 90,000. We are expected to calculate the annual and hourly depreciation respectively for the equipment. So if we are to allocate 2% for insurance and 10% to maintenance, so we'll use the two available methods. We said the first one is the straight line method, or the simple one, and the second one is the interest on capital outlay, which is the more most frequently used one, but more accurate one. So let us start with the first one, which is the straight line method. Here we have the capital cost of their equipment from the question was given to us as ₦1 million. You can see it here, ₦1 million. Then That is why capital cost is equal to 1 million. Anticipated life is equal to 5 years. Then is expected to work for 1,350 hours. Then the resale or scrap value is 90,000 naira. That is after working for 5 years. We sell it as scrap value for 90,000 naira. Then we also have here, we want to calculate, the first thing we need to calculate is the annual depreciation. And for us to calculate our annual depreciation, we will subtract the costs of the equipment, the capital cost, from the scrap value or the resale value, which is 90,000, and we divide by the total number of years, that is anticipated life, which is 5 years. It gives us a total of 182,000 naira. Then we next we calculate is hourly depreciation. So having gotten the value of 182,000 naira from the annual depreciation, remember from the question we were told that the equipment will work under 1,350 hours. So we divide it by that sum, by the annual depreciation, which will give us 134.8 naira. So this is the rate at which the equipment will be depreciating, that is on hourly basis or hourly rate. Then here, after that, we have to add the 2% insurance. 2% of this costs, we are going to express it in percentage, which in percentage we divide by 100. Dividing 2 by 100 give us 0.02, and then we multiply it by 134.8, which is equal to 2.7. Then we also add maintenance costs, 10%. Remember, we still have to divide by 100 and multiply by 134.8 as our hourly depreciation, which gives us 13.48. Then our hourly rate will now be a sum of this hourly depreciation plus the 2% insurance plus the 10% maintenance cost, which will give us a total of 151 naira. So that is our hourly rate. So we look at the second method, which we said is the more accurate method and most commonly used method. This method is the interest on capital outlay, and we still have the same sum for the equipment, which is 1 million naira here, and we will have to add compound interest for this sum, compounded on for a 5 years period at a rate of 8%. So compound interest for that, for 1 million for 5 years at 8%, is equal to 469,300. So using a compound interest formula, we obtain this value. So when we sum this value to the 1 million, it will give us 1,469,300. So that is the total amount we get by adding the capital cost with the compound interest. Now we have to deduct, next we deduct the scrap or resale value. So we'll deduct it from this. We'll obtain a total of 1,379,300. So once we have this, next is we consider insurance. Insurance of the capital cost of the 1 million naira is 20,000. Maintenance of the sum of 10%. Maintenance 10% of 1 million naira is 100,000. So hourly rate, we now calculate our hourly rate, which will be equal to, we will sum this 20%, the 2%, which is 20,000, plus 10%, which is 100,000, to our previously gotten figure of 1,379,300. So we'll sum this, we'll obtain a value of 1,499,300. We divide it by the anticipated year, which is that the equipment is expected to work, which is 5 years, and also divided by the total working hours for the equipment. The equipment is supposed to work for 1,350 hours within that 5 years of operation. So by doing this, we'll have an answer which is equal to 222.12. So that is our hourly rate using the interest on capital outlay method. Then we will also remember that we will add the running costs to this hourly rate. So comparing this hourly rate with the previous one obtained from the simple method is 151, while the hourly rate obtained from the interest on capital outlay is 222.12. So from the result of both, we can see that that of interest on capital outlay is higher than that of the hourly the straight line method. So we now go to the second one. So this first one we've just finished is the one on how to calculate hourly rate for an equipment or an earth moving plant. So the next one I want to calculate now is we'll calculate we'll calculate output and cycle times. So let's see a typical example on how to do that. Calculate output and cycle times. Here we have a typical question on output and cycle times. Here we have a back actor. A back actor is a type of excavator. So that back actor is with we have a back actor with 1 cubic meter capacity bucket engaged in normal trench excavation in a clay soil and discharging directly into an attendant haulage vehicle. Determine its output and cycle times if its optimum output is 70 bucket loads per hour and task efficiency factor is 0.82 from tables. Operator's efficiency factor is 75% and swell factor of 30%. So taking a look at this question, we have a back actor. We said here from the question that the bucket volume is 1 cubic meter. It is carrying out a normal trench excavation in a clay soil. So that is why we have a swell of, we're expecting a swell of 30% and operator's efficiency factor of 7.5%. Then task efficiency factor of 0.82 taken from table. So these are the values given to us, and its optimum output is 70 bucket per bucket loads per hour. So let's see how we can do justice to this question. So the first thing we need to consider here is we have the values here: optimum output given in the question, task efficiency factor, operators efficiency factor given here. Then the anticipated output will be equal to the 70 multiplied by the 0.82 from table multiplied by 75%, which we divide by 100, which gives us 0.75. So 70 by 0.82 by 0.75 will give us 43 bucket load per hour. So we have a volume of the bucket. We said the bucket volume is 1 cubic meter. So multiplying the bucket loads per hour by the cubic meter, the volume of one bucket, it gives us 43 cubic meter per hour. That's the anticipated output of this back actor. Next, the net output allowing for a 30% swell will be equal to, remember we're talking about 30% because we are excavating a clay soil, So, and the swell factor is 30%. So when we divide 30 by 100, we have 0.3. So we multiply it by the 43 and minus from 43, so that we can have our net output, so allowing for 30% swell. So it gives us 30.1. So which we take it approximately as 30. So from the BEME, or the Bill of Engineering Measurement and Evaluation, we are given a total net excavation of 300 meter cube. So that is the total volume of earth to be excavated. So time required will be equal to the total volume divided by what we obtained earlier. Here we obtained the total time. Here we said a net output time allowing for swell. We had total of 30.1, which we approximated to 30. So going back to this, we have the total volume divided by the total hours given to us, gives us a total of 30 hours. Remember that in the previous calculation we said our anticipated output, we got 43 multiplied by 1, which you said is the cubic volume of the bucket of that excavator, which gives us 43. Then considering swell, we reduce this factor to 30, which is 43 minus 43 times 0.3. Earlier said 0.3 is obtained from 30 divided by 100. So we have a net output of 30. So we'll divide it by the volume, total volume of excavation from the BEME, which is 900 divided by 30, which is 30 hours. So assuming a 7-hour day, or 7-hour day of work, that is, we also dedicate 30 minutes out of these 7 hours to maintenance of the equipment. It means the total number of hours for work will be equal to 6 hours per day, or 6.5 hours per day. The total number of hours will be equal to 6.5, because when you minus the 30 minutes or half an hour for maintenance, we'll be left with 6.5. So when you divide the 30 by 6.5, because we've gotten our time required as 30 hours, we divide it by 6.5, we have 4.62, which is approximately 5 days. Next, we need to find out the number of haulage vehicles. So we need to know what number of haulage vehicles do we require. So from the formula here, we have 1 plus round trip time of vehicle over loading time of vehicle. The round trip time is the time taken for the vehicle to discharge its content and then return back to the excavator, leave the excavator, discharge its content and return back to the excavator. So if the round trip time is equal to 30 minutes and the loading time is 10 minutes, loading time is time taken by the excavator to load the vehicle, then it means the number of haulage vehicles required will be equal to 1 plus 30 over 10, which is equal to 4. This gives a vehicle weighting overlap, ensuring that the excavator is fully utilized, which is economically desirable. So with this number of vehicles, 4 trucks, it means the excavator will be optimally made use of. So the excavator will not be idling on the site. The excavator will be able to perform optimally. So that's why we said this gives a vehicle weighting overlap, ensuring that the excavator is fully utilized, which is economically desirable. So viewers, that's where we'll come to the end of today's calculation. As I will come to the end of today's calculation on typical costing methods for construction plants using the hourly rates and using the output and cycle times. If you have questions, you have suggestions, you can drop them at the comment section below this video. If you like the video, or if this video helps to solve your problem, or you understand what we are doing, you can like us and also subscribe to our channel. You can also hit the bell icon or notification icon to enable us release more videos or keep you up to date with our new videos. Thanks once again for being part of this lecture today. My name is Engineer Obonna Nnamdi. Have a nice day.